क्या आप स्टार्ट करें? स्टार्ट करें।
Good morning, sir. Good morning, sir.
गुड मॉर्निंग
सर थोड़ा सा वो YouTube स्ट्रीमिंग के लिए टेक्निकल इश्यू था तो थोड़ा लेट हो गए हम।
ठीक है
सर विद यू डू परमिशन कैन वी स्टार्ट?
हाँ यस यस प्लीज
Good morning, one and all present here. On behalf of Madhya Pradesh Council of Science and Technology, I, Dr. Manoj Rathore, Joint Project Director, welcome you all in Vigyan Utsav, Azadi Ka Amrit Mahotsav. The Vigyan Utsav was inaugurated in the month of September 2021 by the Honorable Minister of State for Science and Technology, Dr. Jiten Singh, and this celebration will be concluded in the month of August 2022. Every month, under the aegis of Department of Science and Technology, under State Science and Technology Program (SSTP), we organize month-wise theme-based programs with the State Council to showcasing the state STI ecosystem in the country. So the theme for month June 2022 is Basic Science for Atmanirbhar. We are honored to inform you all that we have inaugural address of Dr. Anil Kothari, Director General, Madhya Pradesh Council of Science and Technology, and then we will have a special address of Sri Tasneem Habib, former Chief Scientist and Advisor, Madhya Pradesh Council of Science and Technology, and to focus and address the topics of the this month theme, Basic Science for Atmanirbhar. We have invited eminent speakers, Dr. V. Ganeshan, he is former Center Director, UGC DAE Consortium for Scientific Research and Project in Dean Research, Medicaps University, Indore. We have also Professor Vipin Vyas, Professor, Department of Biosciences, Barkatullah University, Bhopal, and invited talk of Dr. Saurabh Srivastav, Associate Professor from Department of Mathematics, Indian Institute of Science Education and Research, Bhopal. Also, we have success story, and the experience will be shared by Dr. Vilas Shelke. Presently, he is Chief Executive Officer of Rechargen Energy Private Limited, Pune. He have been associated with different projects and program of the Madhya Pradesh Council of Science and Technology. Another, we have young colleague, Dr. Shikha Chauhan. Presently, she is Principal Scientist at Department of Textile and Fiber Engineering, Indian Institute of Technology, New Delhi. She has been beneficiary of MP Council of Science and Technology as a Young Scientist Awardee, and different projects. She is associated with different projects of DRDE and DRDO. So also we have the program is being coordinated by Dr. R.K. Garg, Joint Project Director, MPCST, and Dr. Sunil Garg is in charge of Science Popularization Wing of MPCST. Basically, he is dealing with all the science popularization related initiatives of Madhya Pradesh Council of Science and Technology. So once again, I welcome you all, and I request Praveen to play the video on Azadi Ka Amrit Mahotsav that is composed by Department of Science and Technology, Government of India. Thank you, Praveen. Madhya Pradesh Council of Science and Technology is actively engaged in promotion of science and technology among the students, university and college students, also in society. And now I request Dr. Anil Kothari, Director General, Madhya Pradesh Council of Science and Technology, for his inaugural address. Sir, please.
ओके सभी को नमस्कार। ये जो आजाद अमृत महोत्सव वर्ष है उसके अंतर्गत हम जो विज्ञान उत्सव सेलिब्रेशन भारत सरकार के डिपार्टमेंट ऑफ साइंस एंड टेक्नोलॉजी और मध्य प्रदेश काउंसिल ऑफ साइंस एंड टेक्नोलॉजी के साथ मिलकर जैसा कि बताया प्रत्येक माह में हम एक थीम के ऊपर पूरे देश में कार्यक्रम आयोजित किए जाते हैं स्टेट को फोकस करते हुए। और इस बार की बहुत ही महत्वपूर्ण और इम्पोर्टेंट थीम है कि बेसिक साइंसेस फॉर आत्मनिर्भरता। ये कितना इम्पोर्टेंट है पूरे देश के लिए और हर प्रदेश के लिए अपने आप को विकसित करने के लिए। तो आज इस कार्यक्रम के जो उद्घाटन अवसर पर हम लोगों के बीच में उपस्थित हमारे डिस्टिंग्विश्ड गेस्ट डॉक्टर बी गणेशन जी, जो फॉर्मर सेंटर डायरेक्टर यूजीसी डीएई कंसोर्टियम सर्टिफिकेट है और डीन है रिसर्च मेडिकल यूनिवर्सिटी इंदौर के, इस समय वर्तमान में आप हमारे बीच में प्रोफेसर विपिन व्यास जी, प्रोफेसर डिपार्टमेंट ऑफ बायो साइंसेज बरकतुल्लाह यूनिवर्सिटी भोपाल, डॉक्टर सौरभ श्रीवास्तव जी, एसोसिएट प्रोफेसर डिपार्टमेंट ऑफ मैथमेटिक्स, वेरी वेल नोन इंस्टीट्यूट ऑफ मध्य प्रदेश, इंडियन इंस्टीट्यूट ऑफ साइंस एजुकेशन एंड रिसर्च भोपाल, हम लोगों के बीच में आज उपस्थित हैं। हमारे अपने विभाग के पूर्व एग्जीक्यूटिव डायरेक्टर और चीफ साइंटिस्ट तस्मीम हबीब साहब भी एक 40 साल का उनका अपना अनुभव है बेसिक साइंसेस के माध्यम से प्रदेश में एक्टिविटीज़ को रन करने का, लोगों स्टूडेंट्स को प्रमोट करने का, यूथ्स को आगे ले जाने का इस फील्ड में। वो भी हम लोगों के बीच में अपना एक शेयरिंग करेंगे हमारे पार्टिसिपेंट्स के बेनिफिट के लिए। परिषद के सीनियर मोस्ट साइंटिस्ट चीफ साइंटिस्ट डॉक्टर आर के आर्या जी, वो भी हम लोगों के बीच में आज उपस्थित हैं। प्रोग्राम कोऑर्डिनेटर डॉक्टर एम के राठौर जी, डॉक्टर गर्ग जी, सुनील गर्ग जी, डॉक्टर R.K. गर्ग जी, और बहुत इम्पोर्टेंट जो आज बात है कि आज कि हम लोगों के बीच में डॉक्टर विलास सेलके और डॉक्टर शिखा चौहान, they will share their stories, how basic sciences and the initiative of MPCST benefited them उनके कैरियर के लिए, और वो अपना एक एक्सपीरियंस शेयरिंग हम लोगों के बीच में। तो वी आर वेरी मच थैंकफुल टू ऑल इनवाइटेड स्पीकर्स एंड गेस्ट, और हम स्वागत भी करते हैं इस प्रोग्राम में आप सबका मध्य प्रदेश काउंसिल ऑफ साइंस एंड टेक्नोलॉजी की तरफ से। ये हम सब जानते हैं बहुत अच्छे से कि आज के इस दौर में बेसिक साइंसेस कितना इम्पोर्टेंट है, इसके ऊपर बेसिक रिसर्चेस कितनी इम्पोर्टेंट है, और किसी भी देश की सोसाइटी की यदि हम कहें कि एक सोशल और इकोनॉमिक डेवलपमेंट का क्या क्राइटेरिया है, तो उसमें कितना एडवांसमेंट इन बेसिक साइंसेज है किसी भी कंट्री में और सोसाइटी में, ये इस पे डिपेंड करता है। और ये आज किसी भी देश को हमें यदि आत्मनिर्भर बनाना है, डेवलप्ड कंट्री बनाना है, तो इट्स वेरी मच इम्पॉर्टेंट टू हैव एडवांसमेंट इन सोशल बेसिक साइंसेज। और हमारे इंडिया में भी फॉर्चुनेटली हम यदि देखें तो इंडिया में बेसिक साइंसेज का हमारा एक बहुत ग्लोरियस पास्ट रहा है, हमारे एमिनेंट साइंटिस्ट, और हमारा एक जो ट्रेडिशन ही रहा है कि हम बेसिक साइंसेज के ऊपर इंडिया में बहुत रिसर्च हुआ है, बहुत काम हुआ है, और उसको पूरी दुनिया ने इसको रिकॉग्नाइज किया है। तो आज मैं यदि बात करूं कि द पीसी रे साहब, यदि केमिस्ट्री की बात करूं, एक उदाहरण देना चाहता हूं दो तीन। तो उन्होंने द हिस्ट्री ऑफ हिंदू केमिस्ट्री लिखी, तो केमिस्ट्री के क्षेत्र में भारत का क्या योगदान रहा है और साइंटिस्टों ने किस तरीके से काम किया, बेसिक साइंसेज में हम कहाँ थे, ये आप बहुत बखूबी जान सकते हैं, समझ सकते हैं। और उन्होंने बहुत इस्टेब्लिशमेंट किए हमारे यहाँ R&D इंस्टीट्यूट्स के और यूनिट्स के भी, कि बंगाल केमिकल्स यदि आप देखें तो ये एक एग्जाम्पल है कि बेसिक साइंस में इंडिया किस तरीके से उस समय से आगे रहा है। यदि हम JC बोस की बात करें, हमारे और रामानुजम साहब की बात करें, तो मैं ये कहना चाहता हूँ कि बेसिक साइंस का ऐसा कोई एरिया नहीं है जहाँ इंडिया का बहुत अच्छा पास्ट ना हो, हमारे साइंटिस्ट का कंट्रीब्यूशन ना हो। और फॉर्चुनेटली आज भी भारत बेसिक साइंसेस के फील्ड में बहुत रिच है, हमारे यहाँ इंस्टीट्यूशंस हैं, इंफ्रास्ट्रक्चर है, और साथ ही एक्सपर्ट्स की भी एक बहुत हर एरिया में हमारे यहाँ उपलब्धता है। और हमें आवश्यकता इस बात की है आज के समय में कि हम कैसे अपने स्टूडेंट्स को, अपने यूथ को, अपने रिसर्चर्स को और फैकल्टी मेंबर्स को, और जो भी कॉमन इंस्टीट्यूशंस हैं जो लोगों के लिए काम कर रहे हैं, उनकी प्रॉब्लम्स को एड्रेस कर रहे हैं थ्रू द इन्वेंशन, थ्रू द इनोवेशन एंड द रिसर्च वर्क ऑफ बेसिक साइंसेज, उनको रिजॉल्व करने के लिए काम कर रहे हैं। इन सब के लिए सपोर्ट सिस्टम की और आगे लाने की आज बहुत ज़रूरत है। मैं ये कहना चाहूँगा कि मध्य प्रदेश काउंसिल ऑफ साइंस एंड टेक्नोलॉजी इस क्षेत्र में अक्रॉस द सेक्टर हम सभी क्षेत्रों में हम रिसर्च के लिए प्रमोट करते हैं रिसर्चर्स को, यूथ को, और जो भी सोसाइटीज हैं, इंस्टीट्यूशंस हैं, इस क्षेत्र में काम करना चाहते हैं, सोसाइटी की प्रॉब्लम्स को एड्रेस करना चाहते हैं रिसर्च के माध्यम से, टेक्नोलॉजी डेवलप करना चाहते हैं, एनी काइंड ऑफ वर्क विच रिलेट विथ सोसाइटल प्रॉब्लम एंड आत्मनिर्भर भारत, तो हम लोग उसमें सपोर्ट करते हैं। अभी राठौर जी ने बताया कि हम एक जो रिसर्च हैं बेसिक साइंसेस की, उनको हम रिकॉग्नाइज भी करते हैं। हम यंग साइंटिस्ट कांग्रेस करते हैं, उसमें रिकॉग्निशन भी देते हैं और उनको आगे प्रमोट करने के लिए फाइनेंशियल और टेक्निकल सपोर्ट्स भी करते हैं। इसी इसी तरीके से हम किसी भी तरीके का इनोवेशन हो उस और बेसिक साइंस को लेके, उसको भी हम प्रमोट करते हैं। और हमने ये तय किया है कि ये आज की नीड है, आवश्यकता है कि उन्हें आह्वान करते हैं कि आपको इन एनी काइंड ऑफ इंफॉर्मेशन इज रिक्वायर्ड इन द फील्ड ऑफ बेसिक साइंसेज, कौन से अच्छे इंस्टीट्यूट्स हैं, किस तरह से आप कैरियर को आगे ले जा सकते हैं, मध्य प्रदेश काउंसिल ऑफ साइंस एंड टेक्नोलॉजी आपको किस तरीके से सपोर्ट्स कर सकती है, और सबसे इम्पोर्टेंटली कि आप ग्लोबली क्या अपॉर्चुनिटीज अवेलेबल है और ये कितनी इम्पोर्टेंट है इसको समझना है। इस सब के लिए मध्य प्रदेश काउंसिल ऑफ साइंस एंड टेक्नोलॉजी कमिटेड है आपको सपोर्ट करने के लिए। वी वेलकम यू ऑल एनी टाइम, आप हमसे सपोर्ट के लिए बात कर सकते हैं। मैं इस अवसर पे हमारे जो कार्यक्रम आयोजन समिति है उसको बधाई भी देना चाहूँगा कि एक बहुत अच्छे सब्जेक्ट के ऊपर और एक बढ़िया प्रोग्राम आयोजित करने के लिए, और हम एक बार पुनः सारे एक्सपर्ट्स को हमारे जो आज हम लोगों के बीच में अपनी बात रखेंगे बेसिक साइंस के डिफरेंट एस्पेक्ट्स को लेके, उन सब के लिए भी मैं बहुत बहुत धन्यवाद ज्ञापित करना चाहूँगा मध्य प्रदेश काउंसिल ऑफ साइंस एंड टेक्नोलॉजी के लिए, और जुड़े हुए सारे रिसर्चर्स, स्टूडेंट्स, उन सबको मेरी बहुत बहुत शुभकामनाएं। थैंक यू वेरी मच।
Thank you, sir. Thank you very much for your inaugural address and to highlight the role of Indian scientists for Atmanirbharta and inviting and offers various schemes of MP Council of Science and Technology. Now we have a special address of Sri Tasneem Habib, former Chief Scientist and Advisor of the Pradesh Council of Science and Technology. Yes, Sri Tasneem Habib ji is MPhil in Geology and PG Diploma in Hydrology and PG Diploma in Remote Sensing and GIS. Sri Tasneem Habib has served more than 35 years to MPCST. He has developed the methodologies for geospatial techniques for groundwater source finding in the state of Madhya Pradesh way back in 1987-88, which improved the success rate of the groundwater drilling in problematic villages of Madhya Pradesh also. Sri Tasneem Habib is associated with Chandrayaan project at MPCST and guided various projects to suggest water resources and land resource action plans in various districts of Madhya Pradesh. Sri Tasneem Habib is also associated with numbers of projects and programs of ISRO like IMSD, NRIS, CT projects. These are the key projects there. So now I request Sri Tasneem Habib ji for his special address. Sir.
So kind of you. Thank you, Dr. I'm really thankful to the council officials for giving me an opportunity to be part of this important program. As you all are aware that this Azadi ka Amrit Mahotsav that is initiated by Department of Science and Technology, State Science and Technology program way back in September 2021 with a very important theme STI institutions in the state. And thereafter, every month, different themes have been taken up. And this month's very important theme is basic sciences for Atmanirbhar. As you might be knowing that the basic science is widely recognized as an important tool for strengthening the basic research, economic and social development of the country. It plays an important role in all fields of sciences, right, starting from agriculture to artificial intelligence. And with a focus on scientific research, we also need to concentrate on innovation and center of excellence for product development, which will lead us to Atmanirbhar. And the basic objective of this particular program is to understand the need and joy of doing basic sciences. This is one of the important aspects, because slowly people are going away from the basic sciences and they are oriented towards job-oriented kind of disciplines. So this is very important that we should inculcate some kind of interest so that they could enjoy doing basic sciences. Another is to promote self-reliance and indigenization to attain sustainable development and to improve the quality of life through Atmanirbhar Bharat using basic sciences. Another is to stimulate the role of Atmanirbhar Bharat through basic sciences in physics, chemistry. These are the four basic sciences which are required to be promoted. Basically, physics, chemistry, mathematics, and biology. These four are those important basic sciences which are required to be promoted and required to be given the space so that people could have more interest in these disciplines. Basically, what has been observed, I'll be just speaking a few important points because we are here to listen to the experts which have been invited by the council. As you might have observed that discoveries and inventions for the last so many decades are not seen simply because the interest in the basic sciences has reduced like anything. I remember way back in 2012 when Professor C.N.R. Rao was taking review of all the state S&T councils. He emphasized, and at that time, he said that basic sciences interest should be inculcated throughout the country so that some kind of innovation, invention, and the discoveries may come up because the inventions and the discoveries basically come from the basic sciences. So that is very important that the interest in the basic sciences is required to be inculcated. And for that, there are certain important aspects like establishment of basic science labs. We should establish labs in schools. We have observed in various states, in Madhya Pradesh, we have seen that at various places, basic science labs are not very well equipped. So that is need of the hour that at the school level, the basic science labs should be strengthened. And also the tinkering labs in primary schools are also needed to be inculcated. That is very important. And innovative and scientific temper is also to be inculcated in schools and colleges through basic science promotion. These are some of the important points. Basically, states' priorities, if you observe that the state government priorities are also not basically basic sciences because they want to have those kind of activities to be promoted where they could have directly revenue generation. And basically in basic sciences, if you do research in basic sciences, that investment is relatively more and outcome comes out after quite long period of time. So basically in the corporate sector, the importance is not basically towards the basic sciences. So this is now it has come, this is the high time that we should emphasize this kind of point that at least the government should also take up promotion of the basic sciences and that they should allocate some kind of funds to the schools and colleges for establishment of labs for promotion of basic sciences in the schools. This is one point, and one more important point is that because if you basic sciences and basic sciences, application of hello. Yes, please. So basically, the promotion of the basic sciences is definitely required, but at the same time, it is required that this basic sciences should have some kind of linkages with the application aspect of the basic sciences. That is the applied aspect of the basic sciences, and these applied aspects should transfer its applications into the industrial growth. Because ultimately, if we want to go for the Atmanirbharta, for Atmanirbhar Bharat, for Atmanirbhar Madhya Pradesh, we'll have to promote the sciences which could ultimately give us some kind of self-reliance and also the revenue generation, employment generation. Yes, this is also an important point because the jobs, especially in those sectors where multinationals have come up, they are relatively more. In basic sciences, jobs are also limited. So this is also required, and recently actually AIG, GPA and State Planning Commission and MP Council of Science and Technology, these organizations are jointly formulating the science, technology and innovation policy. In that, this point is being highlighted that the budget for the basic sciences should also be increased. It is thought that at least for the R&D, especially in the basic sciences, the budget should be increased at the state level. At least 1% budget should be allocated for this. Another important aspect, because if you see the India Innovation Index, our Madhya Pradesh is standing quite low at 17 out of the total 17 states. It is standing presently at the 13th level, which is required to be improved. These are out of the major states of the country, and we have observed that this is 2021 index which has been brought out by Niti Aayog, and Karnataka is on the top, which is scoring at around 42 point something, and thereafter another is Maharashtra, and then Telangana, then Andhra, and then Kerala. But Madhya Pradesh is coming at the 13th level. So we need to promote this level, and if we want to improve this level, we will have to give impetus to the basic sciences. And another important point is that IPR is also reducing. That IPR, especially in the basic sciences, is required to be promoted, apart from the innovative ideas which are coming from the indigenous technologies from Madhya Pradesh. That is also parallelly required to be inculcated, but intellectual property right is also required to be promoted in the state so that they could have a little bit more interest in doing basic sciences. Science centers, like in Madhya Pradesh, if you see, science centers are very limited. It is required that at least in all the districts, at least small science centers or science corners or science, those kind of centers should be established, where basic sciences principle could be explained to the school-going students or to the college students, and also to the general masses, so that the interest in the basic sciences could be improved. This is another point which I wanted to highlight. And the most important aspect is that the basic science should be linked with the jobs and opportunities in the state and also at the country level. So if some of the points which I highlighted, if these are taken for consideration, then definitely we can have some kind of good impetus on the basic sciences promotion. And ultimately, if basic sciences will be promoted, then invention and discoveries may come up, and ultimately IPR will be improved, and ultimately it will lead to the development of the industrial growth, and then ultimately we will reach to the Atmanirbhar. That is our objective. Thank you very much. I had to make out a very few points, and I wanted that we should listen to the experts which have been invited by the council. Thank you very much, sir.
Thank you very much, Habib sir. Thanks for highlighting the present scenario of Madhya Pradesh in investment and in basic science, and where we stand in the country, and what is the scene of country in basic science, and how basic science can lead for Atmanirbhar. Thank you very much, sir. For Dr. Rakesh Arya is not couldn't join us due to some technical reasons. So now I present the council's initiatives. Praveen, present. A short presentation of MPCST initiatives in basic science. Council, Madhya Pradesh Council of Science and Technology has numbers of programs to promote the science at school level and university levels, where for science awareness program and to create scientific awareness in the society, we have established a regional science center and sub-regional science center at Ujjain and Jabalpur. Also, under the science and technology popularization schemes, we organize the various mega events like various type of scientific Olympiads, innovative science teacher exam, Paschim Bharat Vigyan Mela. Also, we recognize the scientists with the national and state levels awards and we organize district level science fairs also. Next. Next. We have a flagship program of Mission Excellence to promote the basic science and to encourage the students to pursue their higher studies in science. For that, we have Vigyan Manthan Yatra. Every year since last 15 years, we are organizing this Vigyan Manthan Yatra. The beneficiaries are from class 8th to 12th school-going students, where they visit the various laboratories of the country. Every year, we make sure at least 700 school-going students for laboratory, and we provide them fellowship for 5 years if they are pursuing their career in the basic science. So this is the flagship program countrywide is being appreciated for the promotion of STEM and basic science. Next. Also, we have MP Young Scientist Congress. This is also the flagship program of the Council of Science and Technology since the last 37 years. The mandate of this program is to encourage the budding scientists for their research project and plan, where we provide them financial and technical assistance, and so they can associate with the national level institution and laboratory and discuss their work and work with the sophisticated equipment with the distinguished scientists of the country. And also, we have the research projects scheme where we provide the regional coordinated project and mission mode research projects. Also, the basic science projects in the university and colleges where the human resource of basic science we encourage. Next one. Also, Council had developed a Center of Excellence in Biotechnology, where we undertake the R&D programs in various branches of biotechnology and its application. At the same time, we provide the this make accessible to the college level, university level, MPhil and PhD research scholar for their research plans, and also we organize the various refresher course for university and colleges teachers with the sponsored by DBT and DST. Next one. Also, we have central laboratory equipment facility as in the quality assurance laboratory, where sophisticated analytical equipments are available. These are also open for the school, college going and research scholars of the states. So at very low cost, we provide them the all analytical techniques, and various hands-on and training programs are being organizing under this laboratory. So this is also helpful for providing the basic science research in the country. Also, we have plant tissue culture laboratory where we develop the protocol for the traditional and aromatic plant. At the beside the developing the plant tissue culture techniques, we also provide techniques for livelihood generation. That's how these techniques can be helpful for livelihood generation and employment. Also, we have here mandate for mass production of the tissue culture based plants. Next. To popular the science among the students, we have planetarium at Ujjain. This is the hybrid planetarium, and this is also being underdeveloped under 3D theaters, and astronomical observatory where astronomical quiz, Olympiad, and sky watching camps are being conducted by MP Council of Science and Technology. So, MP Council of Science and Technology highly engaged in the promotion of basic science. We have numbers of schemes to promote the basic science in the school and university levels. Thank you. सर मैंने तो सभी को बनाया है अगर आपको एक भी नहीं Now I invite Dr. V. Ganeshan, Farmer Center Director, UGC DE Consortium for Scientific Research and Dean Research, MPCST University, Indore. Dr. V. Ganeshan is PhD from Madras University and postdoctor at IIT Madras. He has more than 40 years research experience in the field of low temperature and cryogenics and SPM labs. Dr. Ganeshan has credited to maintain the lowest temperature about 50 millikelvin with high magnetic field at 16 Tesla. That is the record in Madhya Pradesh. Also, he has actively engaged in the collaborative research projects and countrywide has collaborated more than 200 research projects. Dr. Ganeshan has more than 480 research papers in peer review international journals and having more than 10,000. The interesting field of Dr. Ganeshan is low temperature physics, cryogenic and scanning probe microscopes. Also, Dr. Ganeshan is associated with the development of the UGC Consortium for Scientific Kalpaka. He has been there for 6 years and developed the UGC CSR Center and IGCAR Kalpaka. Also recipient of CSR Scientific Excellence Award. Besides all the sophisticated engagement in the research, Dr. Ganeshan is actively engaged in popularizing science and more than 1,000 groups to the fourth chapter and performed more than 6,000 experiments for the popularization of the science. So now I request Dr. V. Ganeshan sir for his invited talk.
Thank you very much, Dr. Manoj. Good morning to all of you. Am I audible, sir?
Yes, sir, audible, sir.
Thank you very much. Just a minute.
Sir, slide share हो रही है.
Yeah, that's what I was trying to get it. Hope that is now clear, na? Full screen.
Yeah, fine, sir.
Thank you. I'm slides are not moving. Just a minute, sir. My slides are not moving. Yes. Thank you very much for MPCST, Director MPCST, and all other officers for this initiative. And I also thank Dr. Manoj Rathore for his kind invitation. I will like to start with this very beautiful sloka of olden days. Gange Jamuna, Saiva Godavari, Saraswati, Narmade, Sindhu Kaveri, Jalesmin Sannidham. This place is very famous in the world Vedic literatures also. But wherever the water is there, one is to have a basic education, and one of the basic education will be the basic sciences. And even those days, they try to have a very nice national integration of rivers. That means national integration of civilization. This we do every day when you take a bath or whenever you do puja, you start with these slokas, saying that we should have to unite together. And in this beautiful Vande Bharat, for the last 75 years, what we were planning to achieve. Some of the slides I would like to really have to share with you. And while sharing this fantastic Vedic verses, I want to share one more of these Mahakavi Subramanya Bharati of Tamil Nadu, a national poet. வீடு தோறும் கலையின் விளக்கும் வீதி தோறும் இரண்டூர் பள்ளி நாடு முற்றிலும் உள்ளன ஊர்கள் நகர்கள் எங்கும் பல பல பள்ளி தேடு கல்வி இல்லாதோர் ஊரினை தீநிக்கிற யாக முடத்தல் கெழுதிருக்கும் அமுதம் என அன்னை கெண்மை குல வழிவையாம். This is Saraswati Vandana, in which it says that every street should have a school and every town should have a university. If you don't have any research, Tedu Kalvi research, better not to have a civilization at all. That's why I would like to have this one to the next slide. And a lot of students have graduated from the consortium. I would like to thank them. The first set of students who did it from my consortium for scientific research by UGCDA facilities, one of national facility. Second set of students are all almost except Sarnakumar are from Ujjain, from MP. Today I would like to take it up two important contributions of the MP in this case of Atmanirbhar Bharat. One of them is very interesting. Sir C.V. Raman, everyone knows, we always celebrate our National Science Day for the discovery of Raman effect and National Mathematics Day for the birthday of Sir C.V. Ramanujan. Both mathematics genius and areas for basic sciences, we know that. Other than that, some of the people we may have younger generation might have forgot, but it is very important, is that we have Baba Research, Baba Atomic Research Center, VRC Baba, his nuclear physics contribution, and Zaha for his nuclear physics contribution, and for the Vikram Sarabhai for the space research. All of us telecommunication would not have been possible. Another unsung, forgotten hero is Bose. Bose-Einstein statistics. Fermi-Dirac got the Nobel Prize. Bose-Einstein got it, but not the Bose. But his invention for very important quantum statistics called Bose-Einstein statistics paved the whole way. Afterwards, using this discovery of bosons, there are more than 78 Nobel Prizes for this. Nowadays, for integral spin particles are known as bosons, and his contribution is tremendous. And then, similarly, for the cases of your mathematics genius, and then I would like to start something with respect to one of the very old Professor G.N. Ramachandran is considered as the father of Indian biotechnology. Something around 75 years back, roughly, what he was about interested to propose something called as triple helix model of the collagen. Very people may not, younger generation might not be aware, but that was one of the oldest, 60, 70 years back. He has a series of nature papers predicting what kind of molecular conformation is needed, and very interesting. Single helix Pauling, double helix DNA, Watson, Crick, everybody got Nobel Prize, but not Ramachandran. So it doesn't mean that after our independence, we don't get much of Nobel Prizes for doing research in India. But then the people are all acclaimed over a period of time. Today, after 70 years at Indore, RRCAT, we have a very beautiful synchrotron radiation facility, especially very beautiful protein crystallography beamline, in which a structure of nice proteins could be, small proteins could be solved. And that's the very beginning. It took about 75 years. It's true for every discovery. It takes about many decades for you to realize something practical, and MP is no more in the background state or whatever. Of course, I agree with our advice that every district should have a science center because our population has gone up. Say Indore being a very beautiful city with all IITs, IIM, RRCAD, a very good educational center. Bhopal is coming up with ISR Bhopal University, many national centers, Manit, and many things. I think they are very good education hub is being between there Indore Bhopal, but it should extend it to entire Madhya Pradesh. Last but not least, my own interest is on liquid helium. Other than the water, the liquid which I like so much is a helium, for it's very interesting. The only one superfluid known to us, and very interesting. Because of these two interests, how we are contributed over a period of 75 years. I'm not an expert in quantum radiation, but we utilized it. It is there in RRCAT, and it is up to tell that India, self-reliance in India has started long back, but fruits have started. We have Indus One with a 450 million electron volt being on rounding around that, and there's a 2.5 GeV ring storage ring of Indus 2 is there, and there are many beam lines over this. It will take long time. I have only 10 minutes. There are a lot of beam lines which you can go to website, you can understand. And consortium is the thing, but UGC and DIA between universities and the DIA facility is a bridge. So you can use any of this beam line. Today I just started out. This is one of the beam lines that we built for an angle integrated X-ray photoelectron spectroscopy. This is the first beam line started working 25 years back. But today we have a fantastic beam line called protein crystallography beam line VX21, PI21. And Dr. R.D. Margay is there. You can able to go to website and see how beautiful This is very interesting, very useful in India. What the dream Professor G.N. Ramachandran had long time. And then we have much more beamlines also, which I don't wanted to now. It takes very long. And lot of research facilities are available, lot of microscopes are available, lot of condensed matter, nanotechnology, everything. You can do lot of things in this small city of Indore. And of course, in Bhopal, it's also coming up with ISER and many things. Here, Tesla is magnetic field. We have very good highest magnetic field in the country and the lowest temperatures and very large amount of work so that you can study the phase transitions. And you know that it's not a 3 states of matter. Now in textbook +2, you have 5 states of matter, including plasma at high temperatures and bosons in condensation low temperature. So it has become very good way of bringing both into the system of young minds into the system. So liquid helium is one example that we need to go. We had very good cryogenic center, very rarely. Our CAT has one, but very limited facility, but IUC has one which can all the users can come and use it. Why it is very important is that there are all these boxes are multi-crore facilities set up by the government of India, DST, and many other things, including UGC, who have given funding to all. We are thankful for all of them. All of them are available on Pan-India movement. It's not that one. Madhya Pradesh is catering this through a Pan-India program where you can see the entire people all over the country are coming and utilizing, getting benefited. MP is supposed to be the highly benefited state because we are situated here. This is what that we like to highlight here. This is one of the world-class facilities being announced by our 2018 by our own government of India. Now, in another few minutes which I have, I would like to say some contributions what Madhya Pradesh has done with respect to MPCST. This is one of the lowest temperature adiabatic demagnetization that you are able to do. I don't want to go to the system. You can able to go to the temperatures of the order of millikelvin, which I show you here up to 80 millikelvin, indigenously developed by the students in our consortium, including our own Madhya Pradesh students. Okay, Sharat Chandra is there, Archana Lakani from this place is there, Dipti Jain, Manju Mishra, many people have contributed here to do that. And then here, this is one of the very interesting photo conductivity setup. If older memories of Manoj Rathore goes that he knows that they are all worked on this system. And MPCST has supported at least a dozen of students with small projects, small work, or a small fellowship, whatever is there. It can be 6 months, it can be 3 years, it can be 2 years, but a lot of good PhDs which I listed in the beginning has happened. This is a simple photoconductivity setup using a spray paralysis, which prepares simple samples like CDS or zinc oxide or whatever is there. Then we develop a photoconductivity with a small locally available LEDs, etc. And using electrometer, you can measure the photo currents and you can study the variation of various nanostructures. Therefore, what is the effect of all these so-called solar energy component photoelectric photoconductive properties? And it is very amazing to say something around more than 50 to 60 high-level reputed papers have come into the system, which I showed you. All these starting points where when I was doing my PhD for liquid nitrogen, like a milkman, I have to go to 8 kilometers to IIT Madras and take a liquid nitrogen. That day I decided I should have a, if at all if I become a scientist, I will make a electrolyzer in my lab. That is what we first got this liquid nitrogen plant lifted from IIT Madras and the helium plant from Free University, Germany. Then we built it up. We don't have money. Then after realizing this, DST has supported the first country's highest magnetic field and low temperature of 2.3 Kelvin. Then it is our own evolution of which built hybridity with Indo-German collaboration. Then the microscopes and many things went on into the system. We started working in many areas, including superconductivity, quantum confinement, atomic force microscopy, tuberculosis, many things there. I don't want to go into detail this if you had go over the period, but for all the things, basic part is that we can do something with our own hands. We used to fabricate, our students used to publish, even simple resistivity, how to make it, how to make electronic circuits, how to build our own systems and publish in an internationally like reviewers scientific instrument. This is what 1996 long back, 25-30 years back. This is what we wanted to. I want to encourage young audiences who are listening here, or message can go through that. Yes, we need to set up certain facilities, but we need to work out to get publications and our own Indian publications like by Indian Academy of Sciences, Pramana is there, Indian Material Sciences there. All my papers during my PhD are in Pramana. There is nothing wrong. I have not lost anything in my race. Therefore, one should be very proud to publish. At the same time, in order to international competitive, our publications have to go abroad also. So this is what we made a sound velocity, then we want thermoelectric power, an alternative energy source for conventional. Very interesting things we have done. Got this is what I showed you. And then we have tried to work on many of the works on polymers. I don't know how many areas we have covered, but I won't wanted to go on. We went all the way down to a few millikelvins. We also make a crystal glows. We see the atomic terraces. We study the quantum phase transitions and many things. What I want to tell you in these two examples which I gave you is that it took 75 years for India to make one synchrotron radiation source and a beam line, which is multi-thousands of crore have been spent. And in order to make now the facilities available to RRCAT, and you can go through with UGCTA consortium also. And no doubt, it is one of the very good national facility and very beautiful. And also, at the same time, I also demonstrated that using a very small indigenous work tools with the hybrid of high power DTT development of photoconductivity, which we have started with a small project with MPCST, go all the way to a very high level, is possible without any compromising the quality. So my only request to the young audience, students who will listen this or is listening or will listen this through any of the YouTube channels, is that you can make something on your own hands and be confident and publish it in higher. Unless you go into peer-reviewed journals, our quality of the PhD students will not go. Our basic science is very important. Please understand, Ujjain and Nalanda are the oldest universities what our civilization knows, and even in the so-called Babar Yug, Bhagwan Sri Krishna has to come to Ujjain to learn his basic sciences. It's very important. Madhya Pradesh is not lacking in basic sciences. Maybe we would have slept for some time, so we should wake up, and we have been doing very good. But I really concurrent idea of our advice said every district should have very good, well-equipped science center, which is available for the students reasonably at a free of cost, so that they can come and do without fear of the economical burden. They can do research. And I thank the MPCST. More than that, it will take more time. I have much more, but so thank you very much. Thank you. Hello?
Thank you very much, sir.
Yeah. Because of timing, I closed it. Thank you.
Yeah. For your kind presentation and presenting the sophisticated equipment and to encourage our young scientists to focus on quality research in basic science and related areas. Thank you very much, sir.
Thank you.
Now, I would like to invite Dr. Vipin Vyas, Professor, Department of Biosciences, Barakatullah University, Bhopal. Professor Vyas is associated with the many technical bodies, like member of IQAC, core committee for incubation center, member for medicinal garden committee, and his expert member for MP State Wetland Authority, IFCO. His technical support support group on biodiversity for Narmadapuram. Also, Dr. Vyas is academic advisory committee member of IFCO, Institute of Environment Management in Bhopal. The Professor Vyas is associated with the various institutions as a resource person, like Regional Museum of National History, Ministry of Environment, Forestry and Climate Change, Government of India, Ministry, Madhya Pradesh State Biodiversity Board, Environment Planning and Coordination Organization in Bhopal, and the Regional Institute of Education Bhopal. The current area of research of Professor Vyas is assessing ecology, integrity and health of aquatic ecosystem using multimetric indices, and also the conservation and culture of small indigenous species for nutritional and economic security. Professor Vyas has been served as a in-charge head in various departments of Bharat University, Bhopal. So I request Professor Vipin Vyas for his invited talk.
Thank you very much, Dr. Rathore. I think I'm audible to everybody.
Yes, sir. Yes.
Okay, thank you. So thank you for inviting me to interact with the, particularly with the young students and research scholars who are joining this very good event organized by MPCST, with DST and other organizations. Thank you very much, DG Saab, for giving me this opportunity and the team organizing this event. So let me share my small presentation because we have many eminent speakers in this session, and particularly we want to hear the experiences of our scientists come entrepreneurs who have joined this session. So I'll take very little of your time, and we'll discuss some important issues which are uh, related to biological science particularly. My presentation is visible to everybody, I suppose.
Yes, sir, it is visible.
Okay. So, as Dr. R.K. Garg has shared a document of DST, which focuses on the objective of this particular program, and the main objective was to how the students are motivated towards the basic science, because in the university we have been experiencing for the last 10 or 20 years that students are losing interest in the basic science, particularly in life science, bioscience. So this particular event is it is very rightly pointed out towards the interest of students in basic biology and basic bioscience subjects, because the other eminent speakers, they will address their own area. So I'll discuss about the basic biology, basic biological concepts, and how they are helpful. One more thing is there in the objectives, I have seen the word sustainable development. Sustainable development is very much in, it is in the discussion nowadays. It is very important issue. So we will discuss how this basic biological concepts can be helpful in sustainable development, and how our young students and researchers can contribute to this sustainable development, and they get better opportunities in this field also. So let us very quickly, we will discuss all these things. So as we know that basic research, as the eminent speakers earlier to my presentation, they have already discussed on this issue, that why this basic research and why this basic science is important, because it is done for the to add something to the already knowledge we have, to add something to the existing knowledge, and it does not have immediate any effect on the on any type of discovery. And the goal is to understand the basic function of the strange phenomena which we don't know, we never knew about that. So we try to understand the function of, or to discover the strange phenomena which is going on in the nature, in the life, in physics or chemistry or mathematics or biology, whatever it is. And after some years of basic research and some contribution of application point of the basic research, it can lead to breakthrough in a new invention or in a new method that can contribute to the problem solving efforts which we are facing today. And today, being a biological scientist, we will discuss some important issues like biodiversity loss, climate change, environmental degradation, food security. These are some of the important areas where the basic biological science can contribute. And we are in university or also working in this field. MP Council of Science and Technology is also working in this field. Many other organizations in the state, they are working in this field. But the only thing is, we have to start a concerted effort to integrate all these resources and activities, and to start again with a new approach, this basic research, to solve the problems. See, these are some of the basic steps, how this basic research starts, and what ultimately this basic research gives us. See, the whole science is based on the curiosity. So the research should be on, it should be a curiosity driven research, that is basic research, how the plants are growing, how they are growing in stress conditions. These are the curiosity. This curiosity driven research actually triggers the specific mechanisms. Then it triggers to applications, how this basic knowledge can be applied, and then the techniques are matured and they are then applied to the field. So these are some of the steps normally we follow in developing a technique or a established scientific fact. It actually starts from a simple curiosity in the mind of a scientist that how this process is going on. This is the beauty of basic research, which leads to a technique, mature technique, and we have to see through various phases of this basic research in due course of time. So it takes time, but ultimately this basic research is the only the foundation of the techniques which we are using today. See, because as I told earlier that we are also focusing on the sustainable development. So you can see in this graphic that basic biological research particularly, it has so many facets like environment is one. So we can contribute to sustainable development. Climate change is one area where this basic research is applicable. Natural resource management, how this conservation and management of natural resources can contribute to sustainable development. If we take health, we have seen in last 2 years how this basic research has further contributed to the applied research, and we have developed so many drugs, vaccines and everything. So drug discovery, epidemiology, disease of vaccines of different diseases are there. Then food security is one. So using food biotechnology, bioinformatics is to analyze the data available with us. The big data of various biological processes are available with us. So we have to analyze them with the help of bioinformatics. Pharmacogenetics are there. Then if we go for biodiversity, loss of biodiversity, which is one of the important issue today. So molecular taxonomy, we will discuss in detail, DNA barcoding, and so many other important modern techniques we are using today. That is the whole thing is behind the basic research in the biological field. So how important this biological field is, our young friends can understand this thing. As we were discussing about the sustainable development goals, which the process or the discussion or the deliberation is started from way back in 1972 from the Stockholm conference, then we led to Earth Summit and all the conferences. And finally, we reached the point where we set 17 sustainable development goals before the whole world. The UN proposed this thing, and all the countries, including India, has accepted this thing, that we will be working for these 17 sustainable goals, and we will see how some of these goals can be addressed by the basic research and basic science. So first is zero hunger is goal number 2. It as the title itself indicates that it ensures the food security to everybody. So we have to produce more and more food, either in the field of agriculture or in the field of aquaculture or the food processing industry, because we have seen particularly in India, we have seen that in 1 year we have more production of some particular commodity and the prices go down, so farmers have to face a great loss in their agriculture and other activities. So we have to do something for food processing also. So this basic research in the field of agriculture, in the field of plant sciences, in the field of I have taken only one example of aquaculture, but animal husbandry is there. That is also a solution towards the food security. So basic research, how these species react in the environment, how can we make the species more productive. So that is also a very important issue in food security. And with the help of basic biological research, we can contribute to this food security. And that is the second important sustainable development goals of United Nations. So that we have to address with the help of basic science. And we are working in this field in Madhya Pradesh, particularly the institutions like I have already told that our institution, some other universities, MP Council of Science and Technology, even ICER, CSIR labs, ICR labs, they all are working towards this Atmanirbharta while doing our own research, our own basic research, our own applied research, and to make the country, the state in the field of food security to achieve this zero hunger goal of United Nations. So we are working in this field. Climate change is again, we all are facing, everybody is discussing about climate change, and particularly the last month of May, we have seen many reports in the newspapers and news channels that we are facing the worst stage of climate change, and we have experienced it in this in the last month, that acute heat was there, and the heat waves which were actually we were expecting in the last week of May, but it is preponed, and in the second week of May we experienced the extreme heat conditions. So this is the basic biology comes into picture here, because the worst hit areas in the climate changes are biodiversity, and that too our food system, as we discussed earlier, that we are dependent on the agriculture, aquaculture, animal husbandry, food processing. So all these factors, they get badly affected because of this climate changing climatic condition, whether it is temperature, erratic rains. So these all are floods, drought, everything. So this is affecting the biological system, and this biological system in turn, it is affecting our food security. So to understand the basic biological concept of a species, the physiology of the species, that can be helpful in understanding the basic structure or basic phenomena of the plants and animals, how they are reacting to the climatic stress like heat and drought and other things. And with the help of this basic biology, basic physiology of the species, basic reproduction of the species, we can contribute towards the mitigation stage, towards the adaptation stage, towards the resilience stage. Like the scientists are working for developing such crops which can grow in less water condition or less irrigation. So actually it depends on the basic research of plant sciences, where we study the water requirement of a plant, and if water is in stress conditions, how this plant can react in the physiology, in the reproduction system. Likewise, in a species, if we consider in Barkatullah University, we are working on several fish species. Because of the changing climatic conditions, they are facing a challenging situation in breeding, particularly fish breeding, because it is the breeding which increases the population of any species. So if breeding is affected because of this climate change, definitely it will affect the population and our food security also. So we are studying the basic breeding biology of the fishes, which was earlier the researchers used to study, but in last 2 decades, I think we have lost our interest in the basic research, and we directly went to applied research. So now we are again studying the basic biology of the species, whether it is plants and animals, to help them to see to face the climatic stress, and we contribute towards mitigation of climate change, adaptation towards climate change, and more importantly, resilience. How can we become resilient? How our bioresources can become resilient to this changing climatic condition. So basic biological research in climate change studies are very important. So our young students can understand that climate change is also dependent on the basic research which is done in the field of biology. So this is one area where we can contribute. Natural resource management. See, in a mega diversity country like India, we are basically dependent on the natural resources for our food systems, for our say livelihood security, for our economic growth, and our maximum part of our GDP comes from the natural resources we are having in this country. And not only our country, but most of the underdeveloped countries, they are having rich natural resources, and if these resources are managed properly, these countries can develop, they can attain these goals, sustainable development goals. Like you can see here that sustainable goal number 14 and 15, they are actually focusing on the water and land resources available, and the biodiversity, encompassing these two important biomes of aquatic and land ecosystems. So unless until see, we are working on the conservation of tigers. How we are conserving the tigers? Unless until we don't know the basic ecological concept of tigers. What is the food chain? If food chain is disturbed, we have to replace it with some alternative. So these are the basic concepts of ecology which are actually contributing towards the conservation and management of natural resources. So we have to study the basic ecological concepts of a particular species and an ecosystem also. So these are some of the important factors which are contributing towards these two particular goals of this life below water and life on land. These are the two important sustainable development goals. So again, we can see here that basic ecological concepts are only contributing towards the conservation of these resources. Health is one important factor. We all have experienced in last 2-3 decades that we have developed new drugs for various types of diseases, and particularly our natural systems are also contributing towards the health issues, particularly in the area of this COVID period. We have seen that many natural drugs have come up, particularly for immunity as immunity boosters. So at that time, we came to know that our immunity is the most important thing to fight any disease, and these vaccines and other things comes in the later stage. So to increase the immunity, we have discovered so many products are there in our Ayurveda and natural science and traditional knowledge. But in last 2 decades, we actually understood the importance of these natural products, these important issues, which are which contributed towards the enhancement of immunity, so that we can fight with the diseases, not only corona, so many other diseases are there which we can fight with them with the help of this immunity boosters. And we have developed vaccine also. That is a history that we have developed a vaccine much earlier than other developed countries could develop vaccine, and we have very successfully vaccinated a large population of our country, which is actually with this population we have vaccinated is more than total of the total population of many continents also. So this is achieved because of the basic research we have been doing in our area. One more important thing which I was trying to discuss is one more important thing of biological science was taxonomy. Taxonomy is the basis of the biological systems, the flora and fauna and the biodiversity. In last 20-30 years, those who are attending this session are from biological science. They must be knowing that taxonomy was once the most important branch of biology. But in last 2-3 decades, we have lost our interest in taxonomy, and we thought that this is the redundant type of branch of biology, and we started working on some other aspects. Nowadays, we are losing the biodiversity at a very fast scale, and that had led us to see once again thought of taxonomy. And nowadays taxonomy has become very important issue in the biological science research. And this basic taxonomy has taken a new it has transformed into molecular taxonomy. So we are now working in taxonomy field. We are now working in the molecular taxonomy field. MPCST is also working. Dr. Garg and Dr. Anita has worked in this field. We are also working in this field. Many other universities in Madhya Pradesh, they are also working in this field. So we are trying to be Atmanirbhar enough to fight this challenge of to understand the biodiversity. I have read somewhere that this physicist, they have measured the distance from Earth to Moon in inches. they are very successful. But we biologists, we still could not enumerate all the plant and animal species. So we are far behind because we have lost interest in the taxonomy. That is the basic research in our area. So taxonomy, molecular taxonomy, that is also very important. So these are some of the important issues of basic biological science, which can contribute to various sustainable development goals set by the United Nations, and India has also accepted it. Madhya Pradesh is also working, our state is also working in this area. Our planning commission, state planning commission is working, and regularly Honorable Chief Minister is monitoring the indicators of sustainable development goals we have achieved. So directly, indirectly, by doing basic research in biology, all these institutions are contributing towards the towards achieving these sustainable development goals, and Madhya Pradesh is also working in this direction. So these were some of the important topics, important aspects in the field of basic research in biological field, and I think our younger generation now they will understand how this basic research is important, how scientific discipline is very important, how scientific temper is very important, and how it is very important to understand the things in the totality with a rational thinking, so that we can solve the not only environmental problems but so many other problems which we are facing today. So I think this is enough in a very limited time. I tried to discuss all the important issues, although some of the issues I left some of the issues because of paucity of time, and we are very keen to listen to the other eminent scientists, and particularly the scientists turned entrepreneurs. I know personally Dr. Vilas Shelke. So now floor is yours, Dr. Rathore and other speakers. Thank you very much.
Thank you very much, Professor Vyasji, for your wonderful talk and addressing the issues of how basic research can contribute to achieve the sustainable development goal, like food security can be addressed, climate change, national resource management, and other various sustainable development goal can be achieved through focus on biological basic research. So thank you very much, sir, for your wonderful talk. Now I would like to invite Dr. Saurabh Kumar Srivastav, Associate Professor from Indian Institute of Science Education and Research. Dr. Saurabh has built his career in mathematics and his PhD from Indian Institute of Kanpur, and received UGC CSI prestigious fellowship, and he has received the Chancellor Medal at Banaras Hindu University for securing highest marks at master level courses in all disciplines. Dr. Saurabh has numbers of international publication in peer-reviewed journals, and he has contributed in various conferences, awareness programs, and other training programs through ISAR, Bhopal, and Harishchandra Research Institute, Allahabad. So now I will request Dr. Saurabh Srivastav for his invited talk. Dr. Saurabh.
Thank you very much for the kind invitation. So can you hear me?
Yes, sir.
Okay. So it is really a great pleasure to participate in this, and I must thank the MP Council of Science and Technology, and in particular Dr. Garg, for the invitation. So, I mean, I'm kind of attending this kind of program for the very first time, and I must say that it is really encouraging after hearing, the previous speakers, that Madhya Pradesh has, so many initiatives in the field of science, and then also in terms of these outreach programs. These are, I mean, Madhya Pradesh has a huge potential, definitely, and a lot of new things are coming up. And I mean, if you, I mean, I must tell you that ISERs, they were established to promote scientific research and teaching in basic sciences only. So, we very much understand the need of promoting basic sciences, because that is the mandate of our institute, for example. And we are here. I mean, tell you a little bit about ICER, so that in future you can get in touch with more and more people over here. That we have people working in all the basic fields of mathematics, physics, chemistry, biology, and computer science, and even in some engineering sciences. And the focus is to basically promote research in basic sciences and train students towards basic sciences. As all of you have said, that why the basic science is important, we all understand that. But as Professor Vyas mentioned, that somehow the students these days do not seem to be very encouraging to take up studies in basic sciences. They want to think that this probably is not going to fetch them a very good job, and so on. So that requires a little bit of work. I think all of us try to do that. So what we do at our end basically is we try to tell them that any scientific innovation or any innovation in technology, it is going to need you have a very good understanding of basic science. And we try to make some of the basic courses very interesting, so that they can learn and they can ask their own questions. So I will not take much time, as I was told that this is really for going to be for basic science purpose. So I have prepared a brief presentation, and please excuse me, because I see in the audience there are senior scientists. So please excuse me. This is really meant for school level children, and the idea is I want to demonstrate that how simple and basic concepts in mathematics, they can lead to some very encouraging and very sort of difficult research problems. Okay, and the background you need is basically, I mean this talk which I'm going to deliver, even a class, I would say second or third student can also understand. So let me just share my screen. Just a second. There seems to be some issue. Have to, please give me a second, because it says I cannot share my screen. Okay. Is there any setting from your end, or?
शेयरिंग में आप ये कर सकते हैं.
So can you see the screen? Somehow it's not coming. I think I will have to sort of log out and log in again. Something like that I have to do.
Kind of.
Yeah. Or maybe should I send you this slide here in the chat, or you can share it? Is that possible?
सेटिंग से बुलाने शेयर हो जाएगा या मेल पर बुला.
Okay, you may send through mail also, so we can try from here, and meanwhile you can log out and log in again. So
Sure. Because I think there's some issue here. It doesn't allow me to.
And okay. And otherwise, without slide, you can also share your ideas.
Okay, that is also fine. But
That is fine.
actually, it would be interesting to show you something. That is what I wanted to.
ID.
So okay, so what I'm let me just speak without the slides. So, I mean, if you just forget anything and everything that we know, the very first thing we start learning is basically numbers. Correct? We start learning numbers 1, 2, 3, and so on. So in this process, and it's not that that somebody has to teach you. These are the things which come naturally to us. And then we move on with numbers. We see that everything else is basically built using numbers. Okay. In today's life, whatever we do without numbers, we cannot really imagine our life. Okay. Because if you talk about any transaction, you talk about time, you talk about anything which is like you want to compare two things, you want to quantify two things. So anything which we do in our day-to-day life, mobile phones, banking, finance, in hospitals, any test we go, there are some numbers attached to it. So basically numbers are the most fundamental and basic objects which not just mathematicians, everybody needs. So how do we basically start learning numbers? We try to then add numbers, we try to subtract numbers, we try to multiply them, and we try to sort of divide them also. Correct? So what I was actually planning to talk about is like how these basic operations lead to some problems which are still unsolved, and people have been trying, let's say, for several hundred years. Okay, from the dawn of civilization, I must say. Okay, so if we try to write, let us say, number 2 or number 3 and number 4, how do we factor into smaller pieces? So for example, number 2, I can divide it by 1 and 2. There is no other possibility here. When I go to 3, the same thing happens. When I go to 4, you notice that number 4 has got another divisor which is like 1, 2, and 4. So here you can divide it into 3 different ways. You can divide it by 1, that means you can divide it into 4 equal pieces. You can divide it by 2, that means you can divide it into 2 equal pieces. And if you divide just by the number itself, then you just have the 1 piece. So these are the basic things. And why do we divide anything? Because we want to understand something. So as a whole, sometimes we cannot understand it. So we divide the problem into smaller pieces, and that is the basic concept of division. And again, this is a natural thing to do. So in this process, we see that certain numbers, they can be divided by only 1 and the number itself. And these numbers in mathematics, we call them as prime numbers, correct? So prime numbers, basically, they are the building blocks of everything that we can do with numbers, and hence it becomes very important to understand the prime numbers. Okay, can you hear me?
Yeah, you are audible.
I'm really sorry that this sharing thing is not working for me.
It's all right.
Yeah, so but I will anyway send you the slides, so if you have to probably upload somewhere, you can do that. So this process leads you to different groups of numbers. One is like the numbers which are divisible by only 1 and the number itself, and the remaining ones. So the remaining numbers, we call them as composite numbers. Okay. So what I was actually thinking to talk to today, that when we are dividing a number by other smaller numbers, then we try to understand these numbers by which we divide a given number. They are called the divisors. Correct. So if we look at the divisors, how is the number is basically made up of these divisors? That is what I wanted to basically tell you. So if you look at, for example, number 4, and I look at its divisors, which are smaller than 4, they are called the proper divisors. So they are just 1 and 2. So if I try to add 1 and 2, what do we get? We get just 1 plus 2 is 3. We do not reach 4. Whereas if I do this process with 6, let us say, so I'm going to get 1 plus 2 plus 3. And these 3 numbers, which are the proper divisors, they make up the whole number 6. Okay. So this property of this 6, this basically tells us that it is perfectly balanced with respect to its divisors. that it actually is made of its divisors. Okay, so that actually leads to a category of numbers which we call them as perfect numbers. And what are they? They are just basically look at the proper divisors. That means the divisors which are smaller than the number, and add them up. And if you do that, if you are getting the number, you call such a number as perfect number. Okay, so this is such a simple thing which anyone can relate to it. So there are three possibilities that the sum is going to be either the number, or it can be smaller than the number, or the larger than the number. Correct. So we get these three categories. The categories where the sum is not equal to the number, they are somehow well understood, and not I mean so much of a problem posing for the purpose that I am trying to tell you. But the second, I mean the category of perfect ones, where the sum becomes the number itself, is somehow very mysterious. So you see that this number 6, 1 plus 2 plus 3 is giving me the number. If you try to look at other numbers and try to see whether we have some other example, and we actually run into a problem in the sense that we do not find quick examples. Okay, so that is that is what makes this something very elementary, something very basic, but we can't really find a quick example. So the next example, if you just try it by hand, you will see that the next example is going to be number 28. Okay, and so basically what one has to do is just look at the divisors of 28, which are going to be 1, 2, 4, 7 and 14, and you just add them up, you get 28. Okay, and then if you continue, you will actually realize that by hand it is going to be very impossible. I mean, it's going to be very difficult to get more examples. Okay, so it's such a simple thing. So in mathematics, what we try to understand is, or what anyone tries to understand is, like, what is this phenomena which is causing to find these examples difficult, and how do we basically find a sort of a path to understand this problem, and how are we going to first of all approach this problem. Correct, because we cannot just go on and check every number and write its divisor and sum them up. Correct, because that is not the way that one can approach it. So this this very elementary thing, and it actually leads to a problem which says that, can we write down all the perfect numbers, or can we say that how many of these perfect numbers are there? And since the numbers are just never ending, so the real question is, are there infinitely many such numbers, and so on. And you want I mean this it will be really surprising to hear that still today we have only 51 known examples of such numbers. Okay, and I can only write I mean I could have written only 4 or 5 examples, because the 6th example onward you need one full page, so it will have hundreds of digits if I want to write a number from this category. So the point is that these things become very mysterious, yet all you need is this elementary mathematics, or elementary understanding of numbers and this division, and yet the problem is so difficult. And why would someone do it? Because these kind of numbers, they help you in coding, they help you in cryptography and so on. So one would like to really know all these kind of situations, but with hands we cannot do much. So there are these programs where people try to use computers or computer programs, and they try to basically find these numbers. And even with that, so far we have been successful only to find just 51 examples, because the numbers become just too large. So this is where you need the concepts of mathematics, to pitch in, that by hand or by computers you cannot really check each and everything, because things just do not end, the numbers do not end. So you need approaches which are theoretical, which are basic in some sense, and to address these kind of basic problems. So what I'm trying to basically demonstrate is very elementary situations. There is so much of mystery hidden. All one has to do is we all learn numbers But with learning, we also need to, ask ourselves that what exactly is happening, what kind of questions we can ask. Sometimes this kind of analysis can lead to some important questions, sometimes, not so important, and you can get the answer. But sometimes the answers are just not available. This problem which I just mentioned, it was first studied like 300 BC by Euclid. Euclid is like one of the, founder of mathematics. But we just know 51 examples at the moment. And there's a very interesting quote by a philosopher and a mathematician, René Descartes. He basically said that perfect numbers, like perfect men, are very rare. So that kind of things. And these people are no ordinary men. I mean, they are the founders of the subject. So how these simple things lead to situations which are, are great research problems. That is what I want to demonstrate. And I had little more, in terms of that what kind of approach we can take up, and how to find a pattern, and how to, sort of systematically understand these things. But for that, I will have to write things and so on. So I think there's no point without writing. So I think I just stop here. I'm really sorry that this thing, I think my machine had to be turned off. That is what it said, that I will have to log out and log in again. Some permissions had to be given from my end, something like that.
Thank you very much, Dr. Saurabh Srivastava, for your wonderful talk, for basic understanding of mathematics and various operation and mystery of numbers of various operations, and why everyone should understand these basic numbers and their operations at initial levels. Thank you very much.
Thank you very much.
Now we move to another phase of this program, that experience sharing by the project investigators, and award is supported by MPCST and by the various agencies of government of India. We have Dr. Vilas Shelke, Chief Executive Officers, Recharge and Energy Private Limited. He has been associated with numbers of projects and programs of MPCST, DSTs, CSIR, and UGC, DACA. SR, he may be a role model of any basic researchers in the physics, as he is now an entrepreneur and doing very well in Recharge and Energy Private Limited. So now I would like to invite Dr. Vilas Shelke to know his success story by his presentation. Dr. Shelke.
Thank you, Dr. Rathod, and good afternoon to all of you. It is a great pleasure for me to be in this Azadi Ka Amrit Mahotsav, and I'm happy to see quite a few good friends here. I think I'm audible and my screen is visible to you.
Yeah, sir. Screen is visible and you are audible.
Yeah, thank you so much. Thank you, Dr. Rathod and the MPCST as a whole for inviting me to this wonderful event of Azadi Ka Amrit Mahotsav. And I see there is a STI ecosystem written on the right side of this brochure. And I consider myself as a product of this STI ecosystem as a whole, being benefited through many of or almost all of these initiatives of Government of India. I was working with Barkatullah University for 22 years. We were actually working on basic science aspects, mainly focusing on multifunctional materials, thin films, and nanomaterials. And we had a quite well-established research credentials with patents, some publications, citation, H-index, and impact factor for the journals. But if you see the career graph for me, then you can see DST and MPCST written all over there, starting with DST Young Scientist Award in the year 2000, and then receiving first foreign travel grant from DST in 2002, and first research project which I received from MPCST, followed by then French Embassy Fellowship, and then Indo-US Science Technology Fellowship, which are now managed by DST again, and then subsequent MPCST projects and travel grants. And there are several of my research scholars who are again benefited with MPCST Young Scientist Award and travel grants and FTYS scheme. So all of my PhD students, I can say proudly that all of my PhD students, they have visited abroad and they were all funded by MPCST or DST or both. And even they keep receiving benefits from DST Women Scientist program. So this was going on, getting too much of from government of India schemes. And then in 2020, I thought it is time to repay to the nation. And I left my job in from Barakatullah University. You hear it right at the top of my academic career. I left government job, and then we incorporated a company, Recharge and Energy Private Limited, in the year 2020, along with my wife, who is a principal scientist at National Chemical Laboratory, and Dr. John Normanton, who is an experienced spin-off launcher from Oxford, UK. So we launched this company and registered it with Startup India. So we are basically working on a rechargeable battery. The battery technology has been developed by National Chemical Laboratory, and it has been transferred to us for the product development. We were a winner of Tectonic Innovation in Clean Energy Challenge by Social Alpha, and then we won Uptech Challenge by Ministry of Heavy Industry. And we are also associated with Niti Aayog through Atal Innovation Mission Program or AIM Prime Program. And currently we are being funded by Ministry of Heavy Industries, Ministry of Electronics and Information Technology, and of course, Ministry of Science and Technology. So now the million-dollar question is, what exactly are we doing? We know that we all need rechargeable batteries for your mobile phone, to your mobile phone towers, to your computers, to your big data centers, urban electricity supply, rural electrification, two-wheeler, four-wheeler, buses, even aeroplanes, and even many aviation equipments. You really need a large number of rechargeable batteries. By the end of this decade, the deployment of rechargeable battery will be around 2 gigawatt hour or 2000 terawatt hour, mostly driven by electric vehicle. So the question is, from where these rechargeable batteries are coming, and it is coming from mostly from the China. The global manufacturing is mostly dominated by China with 80% of their capacity, and United States is distinct second with 8% share. And in India, we really do not have end-to-end manufacturing. So we are dependent on China, and you know how good friend China is with us. So our Atmanirbharta, or our self-reliance, particularly in the energy sector, is vitally endangered. The real world problem is even more critical. The minerals required for rechargeable battery like lithium, cobalt, nickel, we don't have resources for these materials. And these are available in African countries or South American countries. And most of these mines have already been acquired by China. And again, you know how friendly China is with us. So we definitely have a real world problem. So what is the solution for this problem? So we need alternate technology which will not be dependent on these imports from other countries. So instead of lithium ion technology, we have developed alternate chemistry based on sodium ion. For this sodium ion battery, we use an anode material which is porous carbon, and this porous carbon can be derived from agro waste. Any kind of agro waste like sugar cane, bagasse, coconuts, and your even wheat straw. So we can derive a porous carbon from agro waste, which can work as an anode. It can really work as an anode for sodium ion battery. We need a cathode material which can be derived from sodium compounds like sodium chloride, which is abundantly available in India or any country. Desh ka namak is the basic ingredient for our battery. And of course, all other components or all other raw material required for this technology are all domestically available. Another important factor with rechargeable battery is safety. And when it comes to the safety, you know that lithium ion batteries are not flower, they are fire. I mean, they can easily catch fire. You have seen many incidences of Ola scooter and four-wheelers and even an entire cargo ship catching fire with because of this lithium ion battery. So with the safety concern, the sodium ion battery has much better safety profile. And of course, cost is a factor. The cost is very, very low as compared to lithium-ion battery in our sodium-ion battery technology. So we basically do fabrication of electrode. We have done innovation, and we have our innovation has been patented for the materials required for these electrodes. You know that for battery, as such, battery structure is globally the same. All the batteries universally, they have cathode, they have anode, they have separator, electrolyte, and casing. That structure is same for all the battery. There is no patent involved in that. But the innovation is done on the material science part, and the material is required for cathode fabrication, for anode fabrication, and that is what we do. We develop our own proprietary anode material, we develop our own cathode material, and then make a prototype coin cell or a pouch cell, which can then be bundled in the form of bigger batteries. The assembling of these pouch cells are required for making a bigger batteries, and then these bigger batteries can be deployed for various stationary application, e-mobility application, or even your electronic gadgets. So currently these pouch cells are all imported from China and then assembled in India. So there is no technology or no manufacturing as such in India. And we are working in this sector to develop our own technology, to develop our own battery, and to develop our own material. And if we compare the performance of our battery with well-established manufacturer or world-level technology, then we are as good as the commercially available batteries, or even in some parameters which we are even better than these batteries. So the point is that just a simple one message I wanted to convey is that starting with basic science research and moving to the translational research, starting with a small funding of 5 lakh rupees from MP Council of Science and Technology, and now talking with multiple corporate houses for multi-crore funding, and starting with self-reliance or Atmanirbharta of a person, now working for the Atmanirbhar Bharat. Life is good. In fact, life is too good for me. And I can assure you that all of you will be driving electric vehicle powered by a battery which is 100% manufactured in India. Thank you so much. Thank you for your attention.
Thank you very much, Dr. Vilas Selkeji, for making aware about your research, and we congratulate and very proud that you have developed your own electrodes and now manufacturing in India. And this is the story how basic research can lead to the a startup and as entrepreneurship and manufacturing sectors. Thank you very much, Dr.
Thank you so much.
Okay. And now we are eager to listen Dr. Shikha Chauhan. She is MPN Scientist Awardee and also associated in various projects of DRDO. Presently, she is working as a principal scientist in Department of Textile and Fiber Engineering, Indian Institute of Technology, New Delhi. Dr. Shikha.
Hello, good afternoon, sir.
Good afternoon, Shikha.
Yeah, can you hear me, sir? So I'm trying to share my slides, sir, but I couldn't. I don't know what happened. Just a minute. So could you see my slides?
Yeah, we can see.
Yeah, so thank you so much, MPCST Bhopal and Dr. Shikha Chauhan, currently working as a principal scientist at Indian Institute of Technology, Delhi. So yes, I have not made a very technical presentation here. I'm just going to share my journey, basically basic science to applied science. So yes, these are my qualifications and experiences. So I did my Bachelor of Science degree in Physics, Mathematics, and Military Science from 2007 from Government Science College, Jabalpur. Then I have done Master of Science degree in Physics from 2010 to 2012. And then I did my PhD in Physics from Jabalpur, Government Model Science College, a fellowship funded by DRDO. And then I did my postdoc at the Indian Institute of Technology, Mumbai. That this funded by institute. And currently, I'm working at the Indian Institute of Technology, Delhi. This is funded by DRDO. So yes, one thing I want to tell you that when I have taken military science, my BSc time, so I always wanted to do something for defense all the time. I was thinking how I can do. Then when I set my mind for doing PhD, so my guide told me that you have to work with that DRDO funded project, and immediately I said yes, I will do. So that is the first motivation, for my PhD. Actually, that fellowship was the motivation for PhD. And in my PhD time, I have prepared PVA based nanocomposite film and incorporated zinc oxide nanoparticle into the polymer matrix, and it was basically for UV absorption. It's giving very good UV absorption and the mechanical behavior of that nanocomposite film. Then okay, so in my PhD, that I got NP Young Scientist Award and Fellowship by MPCST in 2016. So before I was doing my research work, I was doing my PhD, and we are publishing paper. But always every year, MPCST called for the MP Young Scientist Award, so I applied. So first time, I don't know, I skipped that thing, but the second time I applied and I went and I got that award. And yes, that award played vital role in my whole life, and I got confident, I got motivation, and I got inspiration after this. So first of all, thank you so much, director and MPCST, for this. And then I also got the accomplishment during my PhD, that best oral research paper presentation award in the international conference which held in India. Best oral research paper poster presentation award. It was also held in India. And I went to Hong Kong for presenting my research paper during my PhD. And I got that international travel grant from MPCST. Yeah. So currently, I'm working on design and development of coated and laminated material for the aerostat and airship application, which is funded by DRDO. So since long time, the world is invariably followed by a very steady inspiration to fly like a bird, which can make a move through the air and endless sky. So in order to fulfill such kind of desire, different type of inflatables and which are filled with air as well as gases included hydrogen, helium, nitrous oxide, nitrogen available in the market in various applications such as in various applications, inflatables, air supported structure, inflatable boats, etc. In the recent years of advanced technologies, high altitude areas, I hope, sir, could you see my slides as well? So in the recent years of advanced technologies, high altitude areas, then air systems are subjected to 20 kilometers above from the sea level, and considering great interest. Lighter than air systems may be categorized into two types: airships, unthreated systems, and aerostat-created system. So, the factors which are affecting the altitude are severe weather, jet flowing and wind, viscosity, civil aviation, administration, air traffic layers. The treated aerostate is controlled from the stationary, permanent location and lift supply exclusively the lifting of the gas, including hydrogen and helium, which is loaded in the envelope. It needs no force controlling the altitude or the station heat, and it easily enables maintenance of the payloads. The other side, the uncrated airships is an unmanned, power-led, and free floating vehicle systems in which lift managed by the couple effects of aerodynamics and lifting gas in order to deliver required power required to obtain targets combinations, advanced energy storage, and photovoltaic system. Aerostate may be categorized by a hull configuration: flexible hull, semi-rigid hull, and rigid hull. And the vertical force producing way heavier than air systems, lighter than air systems, and hybrid systems. And the third one is capability of payload, medium lift and heavy lift. The flexible or non-rigid type of hull materials more proposed over other due to the lightweight, simple structures, lower cost manufacture, maintenance, and easily fabrications. And system are greatly engaged in the defense applications, including military surveillance, discovering aerial threats, homeland defense, as well as also used for weather forecasting, network monitoring, telecommunication relay, broadcasting, disaster management, 4G, cell phones, wireless systems, etc. Stratospheric airship can be provide value-effective replacement of the Earth orbit satellite in order to achieve unique data sets associated with science and telecommunications. High altitude airship is having some unique balance advantages over satellites, including rapid reconsolidation of capabilities, low cost of accessing, launching, assisting 24/7 capability, relocatability, exchangeable, load pay, and long duration, a lot more, 12 months and all. So in LTE systems, one of their major structural piece of the envelope, which is maintaining its aerodynamic shape. Aerodynamic shapes, when the LTE systems are subjected to various environmental circumstances, when miscellaneous and the UV rays from sunlight, rain, ozone, atmospheric pressure variation, temperature variations, increasing generation degradation rate of the materials used in external layers of the envelope during that service life. So the envelope should have weather resistant property, cope travelable atmosphere of the hostile environmental. Additionally, hydrogen gas, helium gases are basically used for lifting LTS systems. That's why material should have outstanding gas barrier so that leakage of gases doesn't take place, thereby ensuring long service life. The other necessary requirements of LT envelope are high strength to weight ratio, less moisture, again, lower creep, excellent lower temperature flexibility, good absorption, resistant, improved hydrolysis resistance, conventional aerostate envelope, and generally constructed by polyurethane coated and laminated textiles. So polyester fabric, which is laminated with gas holding layer, in the case of single layered materials, in this quite difficult to fulfill all the requirements mentioned above. Therefore, multi-layer laminated or coated structure are generally made up with the severe environmental order to accomplish all the requirements. So we have developed that very very lightweight and very high strength, extremely low helium gas permeable sample, and basically material at a lab scale as well as a pilot plant scale. But I cannot share here all the information because it is confidential to DRDO. So, but I can show these are some salient features of developed material. It's sustainable, strong for UV exposure, easy to deploy. And for this, we have already applied for patent. And our work is in progress in the artificial weathering for 1,000 hours. So, yeah, thank you.
Thank you, Dr. Srikant, for your presentation and sharing your wonderful journey, and also the megavirus and LTS system and stratigraphic air student, its applications, and we congratulate for you to develop some technologies for DRDO, and we wish all the best for your patents and.
Thank you, sir. Thank you very much.
Thank you very much. Now I request Dr. R.K. Garg, Joint Project Director and Coordinator of this program, for his deliveries. Good afternoon.
Thank you, Dr. Azadi. This is our privilege to extend the top thanks on this one-day webinar on basic sciences on Nirbhar or by the Institute of Science and Technology. Basically, the concept behind of such type of program is from Department of Science and Technology, and two key senior person of Science and Technology, Government of India, are Scientist G and Advisor, C Division, DST, Dr. Rashmi Sarma, Scientist F, DST, and Sri Ravikant Prajapati. So these senior person from DST who engaged continuously in the program of DST organized by various council of the India. So on behalf of MP Council of Science and Technology and participants, we are thankful to all the senior officers of DST in many ways for organizing such type of programs in different aspects of the science and technology. We convey our sincere thanks to our Director General, Dr. Anil Kothari sir, for his vision and commitment for promoting to organize such type of program. Sir, your gracious and valuable contribution and guidance and encouragement, we are able to organize such type of programs in each and every one. Now, I would like to very thankful Sri Tasneem Habib sir, former Chief Scientist and Advisor in the Council of Science and Technology, for his vision. And being with us on this occasion, he delivered a nice lecture in the field of basic sciences and what are the needs of the state and researchers of the state for doing well in the science and technology, and particularly on basic sciences. Sir, we are thankful for your nice presentation. On behalf of MP Council of Science and Technology and our team, we are very thankful and express our gratitude to all the esteemed guests and the speakers of this webinar. Dr. V. Ganeshan, former Center Director, UGC DAE Consortium for Scientific Research and Dean Research of Medical University in Indore. Dr. Professor Vipin Vyas, Professor of Biosciences, Department of Biosciences, Bharat University, Bhopal, and Dr. Saurabh Srivastava, Associate Professor, Department of Mathematics, Indian Institute of Science, Education and Research, Bhopal. All the three guest speakers has covered all the objectives of this webinar, which have been decided and fixed by the Department of Science and Technology Government for the state. So on behalf of the MP Council of Science and Technology, and from we all are thankful to all the guest speakers for accepting our invitation and presenting his nice presentation covering all the aspects of the webinar. We also very thankful our two young speakers and innovators as well as scientists, Dr. Vilas Salvini, Chief Executive Officer, Rechargent Energy Private Limited today India, and Dr. Shikha Chauhan, Principal Scientist, Department of Textile and Fiber Engineering, Indian Institute of Technology, New Delhi, for sharing their experiences and contribution to make this webinar successful. Both scientists cover all the aspects which have been done with the support of the MP Council of Science and Technology, and definitely our researchers and students get some knowledge and some idea from your success stories and your contribution in the field of science. So we are very thankful both of the scientists which are working in the good field using the basic sciences toward the new sciences in the field of science. We are thankful to Dr. Rakesh Kumar Arya for coordinating this program, continuously guidance and supporting us with possible to organize this program. We would like to thank to all state councils and our participants for attending this program. Without your presence, this was not possible to success this program. I assure that we will best possible to do the much better in the field of basic sciences and using the technical support. This program basically organized by a particular team. Our team member are Dr. Manoj Kumar Rathore, our colleague, Joint Project Director from MP Council of Science and Technology, Dr. Sunil Janji, in charge of Science Popularization Division, and all team members are very thankful for doing good work and effort for making this program successful. I would like to place on record of my deep appreciation for the manner in the field of preparation, various type of preparation of this workshop. So all the officials of the council, such as administration, audiovisual department, computer division, Srimati Nilma Agarwal ji or Naveen Kaura, Praveen, all are working last 3-4 days for making this program successful. Finally, we would like to thank all the delegates, participants, and researchers for being with us offline as well online for making this program successful. Thank you. Thank you.
Thank you very much. Thank you.
Yeah.